Now, we have a very simple patrol behavior for the enemy, but a better way to control the enemy's behaviors is to use the AI system. In this lecture, we are going to do some setup work first. Then we're going to cover the patrol behavior in the AI system again. Let's go to the Contents drawer, go to the BP folder, and create a new folder in it. Let's call the new folder AI. Get into it, right-click, then go to Artificial Intelligence. Let's create a behavior tree. Rename the new file Enemy Behavior Tree. The behavior tree is the center place where we manage the enemy's AI. Alright, let's open it. What you are seeing is the graph of the tree, and we only have a root node here. First, we can drag out from the root. Then create a sequence. A sequence node can have a bunch of tasks under it, and it's going to execute the tasks from left to right. I want to add a patrol task to this sequence. So let's create the patrol task first. Click on New Task at the top. For the name of the task, I'm going to keep the prefix and rename the second part to Enemy Patrol. Notice that we are also keeping this file under the AI folder. Let's save the file. Now we have the patrol task opened in the editor. And this is where we make the enemy patrol. Before we start doing anything here, let's go back to the behavior tree and drag out from the sequence node. Let's search for our enemy patrol task. Now we have a task under the sequence. When an enemy is patrolling, it's going to turn around at some point. I want the enemy to pause for a small time after it turns around. Let's drag out from the sequence node again, and we add a wait task. Notice that the wait node has to be to the right of the enemy patrol node, because the sequence node executes its child tasks from left to right. In the details panel on the right, we can see the wait time is 5 seconds. But for now, we don't need to do anything with this wait task. Let's focus on the enemy patrol task. Let's switch to the enemy patrol task. Before we get started, let's do some setup first. Let's go to the enemy blueprint. With the self selected, let's search for controller in the details panel. You can find the AI controller class, and by default, it's set to AI controller. We need to create our own AI controller so we can use our behavior tree. Let's go to the AI folder, right-click and create a blueprint class. Then we search for AI controller. Select this AI controller class. Let's rename it Enemy AI Controller. Alright, now we need to set the AI controller class to the enemy AI controller class we just created. We can see it's here, so let's just select it. Let's open the enemy AI controller, because in it, we need to run the behavior tree. Let's go to the event graph of the enemy AI controller. We don't need the event begin play and the event tick, so let's delete them. Then right-click and search for event on process. Drag out from this event and search for run behavior tree. For the behavior tree asset, let's select the enemy behavior tree. Alright, we're done here. Let me compile and save everything. Then go back to the behavior tree. I'm going to undock this window because I want to observe the behavior tree when we are simulating the game. Let's go to the level and simulate the game. Alright, the behavior tree is working. We can only see the behavior tree for one enemy. You can choose which enemy instance you want to observe from this list. For now, the behavior tree is not doing too much. It's just running the patrol task under the sequence node. But this is a great start. We can switch between different enemies, and the behavior trees are pretty much doing the same thing. And for now, we are actually doing nothing in the enemy patrol task, even though the enemies are indeed patrolling. That's because we are still moving the enemy in the enemy blueprint. So let's move the job into the enemy patrol task. Stop the simulation and go back to the enemy blueprint. Let me also dock this behavior tree window again. Back in the enemy blueprint, we have created these nodes before to detect when the enemy needs to turn around and keep the enemy moving. Let's pack them into a function so we can call the function from the patrol task. First, disconnect the sequence node from the event tick. Then we select all of them. Right-click, select collapse to function. I'm going to name this function patrol. We don't need to connect this function to anything, just move it aside and go back to the enemy patrol task. All we need to do here from the task is call the patrol function we just created in the enemy blueprint. To do this, we need to override a function. This is an event function. It's called receive execute AI. We have the controlled pawn output. This is going to be the enemy blueprint. So let's drag out from it and cast it to the BP enemy. Then we promote the result to a variable. Let's call the variable enemy. I think this event gets called once every time this task starts. Next, let's override another event function. It's called receive tick AI. Like the name suggests, this event happens every frame. So this is the place where we run the patrol function. Let's drag in the enemy variable. Then we can call the patrol function on it. Then let's connect the tick event to it. Alright, now we can test. Let me undock the behavior tree again. Zoom out a bit so we can see the entire tree. Go back to the level and simulate. Now you can see the patrol task is constantly running. And the enemies are indeed doing the patrol stuff. Seems like everything is working great. Let's stop the simulation and go back to the enemy blueprint. I want to add a return value to the patrol function. Because for now, the wait task is never triggered. We want to return a value to let the behavior tree know when the enemy has just turned around. Let's select the first node here. First, we need to add a return node. You can just click this button here. Select the return node. Let's rename the return value to reached wall or edge. Let's compile the blueprint. And we also need to connect this return node to the control flow. Otherwise, nothing is going to happen. So let me move the return node to the end of the graph. Connect the set actor rotation to it. Then let's set the return value to true. And this way, we know that the enemy has just turned around. One thing you need to pay attention is that there is a branch node in front of the set actor rotation node. So when that branch is false, this return node is never going to happen. Another thing is that when this return node actually happens, the function is going to stop here after the enemy is turned around. So everything down here is not going to run, which means the part where we move the enemy is not going to happen. When you return a value with a function, you have to make sure that the function always returns a value. Otherwise, it's going to cause an error message. In our case here, we also need to return a value when the branch is false. But we do not need to do it here, because when the branch is false, meaning the enemy doesn't need to turn around, then we just want it to keep moving. And returning a value from the false condition is going to stop that from happening. So instead, let's copy this return node and paste it down here. Then connect the movement node to it. But we need to make sure that this time we return false. This is going to make sure the function always returns a value. Alright, let's compile and go back to the behavior tree. Now we can see the new return value here in the patrol function. Let's make a branch from it. We want this task to finish when the return value is true, which is when the enemy just turned around. Let's add a new function called finish execute. Then connect the true output to it. Set the success of the finish execute function to true. Alright, this finish execute function is going to tell the sequence node that the patrol task is finished. It's very important that success has to be true. This is all about how the sequence node works. When one of the tasks under a sequence node finishes, the sequence only gets to go on if that task returns success. Otherwise, the entire sequence is going to abort, and the rest of the tasks are not going to have a chance to run. In our case here, we want the wait task to run after the enemy just turned around, so success needs to be true here. If the success is false, then the wait task is not going to run, and the sequence is going to start over with the patrol task. Alright, I hope this makes sense. You can also see the detailed information on the sequence node here. Next, let's select the wait task. We can see the time is set to 5 seconds by default. Let's decrease it to half second. Let me undock the behavior tree window. Then we can simulate the game. Great, this is what we want. Now the enemy stops for a moment after turnaround. I hope this helps you understand how the behavior tree works. For now, the enemy always waits for half a second after turnaround. We can add some randomness to the wait time. Let's stop and select the wait task. Set random deviation to 0.5. Then let's test the game again. Now you can see each enemy waits for a slightly different time. And we are almost done here. Just want to make sure the enemy to the right is still working. Let's stop the simulation. I just want to rename the sequence to patrol. Then we can wrap up this lecture.